Hi, I'm Jim Phillips from Brainfiller.com and ArcFlashForum.com. This video is about the changes to the 2018 edition of NFPA 70E. As in past revisions, there are many changes. Some are minor text changes, but some are quite major. There's significant reorganization to many of the sections as well. New definitions for terms such as working distance, fault current, condition of maintenance, and others, and also an increased emphasis on risk assessment. So there's quite a bit packed into this program. One final item that I'm required to say is that although I'm the vice chairman of IEEE 1584 and the international chair of IEC's TC78 Live Working Committee, the views here are mine and don't necessarily reflect those views of the committees or any other committees that I belong to. Now, let's take a look at the new changes. The 2018 edition of NFPA 70E had quite a few global changes. A couple of them here. All mathematical symbols are replaced by alphanumeric values. So as an example, the symbol greater than is now spelled out with the words greater than. Other changes include the word accident is changed to the word incident, accidental is changed to unintentional, and short circuit current is changed to available fault current. Another global change is with the units. In the past, the units used for incident energy were in terms of joules per square centimeter. However, the arc rating associated with PPE, as well as the incident energy that is on most arc flash labels, is in terms of calories per square centimeter. So calories per square centimeter are now going to be the primary units, and joules per square centimeter will be in parentheses. As a frame of reference, the commonly accepted threshold for where the onset of a second-degree burn may occur is 1.2 calories per square centimeter. The equivalent in terms of joules per square centimeter is 5 joules per square centimeter. As you'll see when we go through the changes, there's a greater emphasis being placed on the risk assessment with the 2018 edition of NFPA 70E. The risk assessment includes the steps of identifying the hazards, estimate the likelihood of occurrence or injury or damage to health, estimate the potential severity of the injury or damage to health, and determine if protective measures are required. There was quite a bit of reorganization with the 2018 edition. All training requirements are now located in 110.2. This includes relocating the Lockout tagout training from Article 120, which is where it was previously located. All Lockout tagout auditing requirements are relocated to 110.1 K3, and in order to continue to improve the standard, basically make it more user-friendly and to flow better, Article 120 has been reorganized for a more logical flow. We're going to see that a little bit later on. The sequence of steps for Article 120 are in a much more logical sequence. There was a minor change made to the scope and what is covered. The word removal was added to this text. So activities such as the installation, removal, the new word that was added, inspection, operation, maintenance, and demolition of electric conductors. The complete text now states that this standard addresses electrical safety-related work practices, safety-related maintenance requirements, and other administrative controls for employee workplaces that are necessary for the practical safeguarding of employees relative to the hazards associated with electrical energy during activities such as the installation, removal, inspection, operation, maintenance, and demolition of electrical conductors, electric equipment, signaling and communications conductors and equipment, and raceways. 90.4 Organization. This was deleted because it contains the same information that's found in the table of contents. 90.4 did have Chapter 1, Safety-Related Work Practices, Chapter 2, Safety-Related Maintenance Practices, all the way to the end with Informative Annex P aligning implementation of this standard with occupational health and safety management standards. Since this was also what was found in the table of contents, it was just simply deleted. 90.4D is a new edition titled Informative Annexes. In this new edition, it's to emphasize that non-mandatory information that's found in the informative annexes is not part of the requirements of this standard. Also, 90.5 was renumbered as 90.4. From my own experience, I've found that from time to time, people will want to treat the information that is in an informative annex as part of the mandatory text of a standard, and that's not the case. So this was added to try to emphasize that the informative annexes are non-mandatory information. There was a revision made to the definition readily accessible. The words take, other than keys, and under two were added. And so the definition now is capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to take actions such as the use of tools other than keys to climb over or under to remove obstacles or to resort to portable ladders and so forth. The definition of arc flash hazard was revised. The term dangerous condition was changed to a source of possible injury or damage to health. And this was to better align with the language that's found in the risk assessment. Well, I can't talk about arc flash unless I show a video from the lab where something's blowing up. So this video that I want to show you, this was a stage test. It was at 600 volts and a little over 22,000 amps of voltage short circuit current. And it was of a bus plug, a fusible switch that you would see maybe on a bus duct. So let's see how this goes. 600 volts, test 21.
3, 2, 1.
One inside the room, under the door. Well, that was pretty impressive. That's something you would not want to have to experience unexpectedly. In a lab, it's pretty cool. But if something like that happened on the job, that could have some pretty negative results. And so remember, the main goal is to always place systems into an electrically safe work condition to try to avoid something like that from ever happening. The definition for the arc flash boundary was also revised. Certain language was deleted, such as at a distance and the reference to second-degree burn. The language now uses the term approach limit rather than at a distance, and it no longer references the second-degree burn, but instead it uses the language at which incident energy equals 1.2 calories per square centimeter. This is an important change because when you're calculating the arc flash boundary, for example, using the equation in IEEE 1584, you're actually calculating a distance from a prospective arc flash source where the energy equals 1.2 calories per square centimeter. The informational note was also revised to reference the Stoll, what we call the Stoll curve, the Stoll skin burn injury model. And this is a mathematical model of skin exposed to thermal radiation, and the report is dated from 1967. The arc flash boundary, the definition now states when an arc flash hazard exists, an approach limit from an arc source at which the incident energy equals 1.2 calories per square centimeter. So as an example here, this is actually a frame from video that I shot in the lab a while back. So this was a motor control center, a staged arc flash test. And so from the source of where the arc occurs, which actually was staged on the bus in this motor control center, the arc flash boundary is the distance where the thermal energy would be 1.2 calories per square centimeter, which is often thought of in the industry as where the onset of a second-degree burn could occur. Now, you have to be a bit careful because the emphasis is this is the thermal energy. Just because you're at a distance where the energy drops to 1.2 calories per square centimeter, there can still be hazards that exist. For example, projectiles, you could see here, the molten copper, and other such hazards. The definition of electrical hazard had a minor change as well. The word arc is now part of the term arc blast. Previously, just the term blast was used. And well, that wasn't really very descriptive because what kind of blast are we talking about? So by using the phrase arc blast, the two words together, we're now actually talking about the blast that could exist as a result of an arc flash. The definition for electrical safety was also revised. The word recognizing hazards was changed to identifying hazards. The text, so that hazards do not cause injury or death, was changed to reduce the risk associated with those hazards. So, identifying hazards associated with the use of electrical energy and taking precautions to reduce the risk associated with those hazards. The definition of electrically safe work condition has the word ensure changed to verify. The text regarding grounding was also changed. It was changed from temporary protective grounding equipment has been applied to temporarily grounded for personal protection. The definition of qualified person also saw some changes. Identify and avoid the hazards involved was changed to identify the hazards and reduce the associated risk. So now it reads, qualified person is one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to identify the hazards and reduce the associated risk. This better aligns with the greater emphasis on risk assessment. This definition is very important. I've referred to it on many occasions in legal and forensic cases. When someone is injured or unfortunately worse, it will come back to, was that person qualified? And you go through the details of this definition, and quite often you could find out, no, the person that was actually involved in the incident was not qualified according to this definition. The electrical safety program. This is a new definition. It's interesting because the term electrical safety program has been referenced in the past, but there really hasn't been a definition. So now this new definition states that it's a documented system consisting of electrical safety principles, policies, procedures, and processes that directs activities appropriate for the risk associated with electrical hazards. Two new definitions: fault current, the amount of current delivered at a point on the system during a short circuit condition, and available fault current, the largest amount of current capable of being delivered to a point on the system during a short circuit condition. Both of these are very important definitions because as part of incident energy calculations, you need to know what the fault current or short circuit current is at the location under analysis. A lot of people think that the maximum fault current is the worst case when it comes to the incident energy. Well, the maximum fault current may be the more explosive case, the more energy per time or per cycle, but you also have to be careful because lower fault currents or minimal fault currents might actually be the worst case when it comes to incident energy. A lower fault current could result in a protective device taking longer to operate. So even though the event may not be as explosive or as much energy per time, with a greater duration, you could end up with a larger total amount of incident energy. Short circuits or faults can take on many forms. In a three-phase power system, if phase A shorts to B, shorts to C, all three phases short together, that's referred to as a three-phase fault or a three-phase short circuit. And in most cases, that would give you the highest magnitude short circuit current. But it's also possible that in some instances, one phase shorting to ground could result in the maximum short circuit current. That has to do with what's known as zero sequence impedance, which is affected by how systems are grounded. When incident energy calculations are performed in an arc flash study, the three-phase case is the case that's considered. Because what can happen is even though most short circuits or a great majority of short circuits may begin as a line to ground event, when you have an arc flash, the plasma that results is conducting. And so even though an arc flash may begin on one phase, that conducting plasma could make contact with a second phase, become larger, and then make contact with a third phase and escalate to a three-phase arc flash. Now, we really can't tell whether or not a single-phase arc flash would escalate to three-phase or not. So being conservative, thinking worst case, the assumption is made that everything is going to escalate to three-phase. In a short circuit study, which is part of what an arc flash study is based upon, a system model is created based on impedances, based on utility data, based on conductor transformer data, and the calculated short circuit currents are oftentimes going to be listed on a one-line diagram. In general, what normally will happen is the short circuit current tends to be greater closer to the source, and the further away the short circuit occurs, the short circuit current tends to decrease because of the additional impedance between the more remote location and the utility system or the source. Here's my cheesy little plug here. The short circuit or fault current calculations are becoming increasingly important, not just for arc flash studies and NFPA 70E requirements, but also for the National Electrical Code. The NEC is having more and more requirements where short circuit currents need to be determined, and in some cases, even included on labels for equipment. As part of the new definitions, there are two new informational notes. Informational note 1 is that a short circuit can occur during abnormal conditions, such as a fault between circuit conductors or a ground fault. So it's really just a clarification of what may cause a short circuit. Informational note number 2 states that if the DC supply is a battery system, the term available fault current refers to the prospective short circuit current. Another new definition is for condition of maintenance. This is an important definition because condition of maintenance has been referenced throughout NFPA 70E, and there really wasn't a definition. So this new definition states that the state of the electrical equipment, considering the manufacturer's instructions, manufacturer's recommendations, and applicable industry codes, standards, and recommended practices. Not sure what to make of this one. Condition of maintenance? I don't think so. Actually, this picture, I took this couple-hour drive south of where I am in Arizona. This is actually taken in the town of Nogales, Mexico. It was at an open-air market, and when nobody was looking, I had to take the picture. Kind of interesting. I'm not sure I would be willing to state that the condition of maintenance here is considered good. This is another important new definition, the definition of working distance. Working distance is a really important part of an arc flash study because when you calculate the incident energy, it's based on a certain distance from the arc flash. So NFPA 70E, the new definition of working distance, is the distance between a person's face and chest area and a prospective arc source. There's an informational note that states that the incident energy increases as the distance from the arc source decreases. So that means the closer that a person gets to the arc flash, the energy is going to increase, and it actually increases pretty dramatically. It's exponentially. And the opposite is also true. If you can increase the distance between the person or the worker and an arc flash, the incident energy will decrease. IEEE 1584 references 3 different working distances depending on the type of equipment. And these working distances are typically used as part of arc flash studies. So, for example, for low voltage distribution equipment, the working distance that IEEE 1584 lists is 18 inches. That's 18 inches from the source of the arc flash to a person's head and torso or chest. For low voltage power equipment, IEEE 1584 references a 24-inch working distance. And part of the rationale for this is low voltage power equipment, for example, switch gear. It's considered that the exposed energized parts are a little further back in the equipment. For medium voltage equipment, such as 5 kV and 15 kV switch gear, the working distance is listed as 36 inches. For similar reasons that we had with the low voltage power equipment, the consideration is that any exposed energized parts may be further back within the equipment. Now, you don't have to use 36 inches. That's just what is listed in IEEE 1584. If you want to use a working distance that's maybe a shorter distance, you can do that. Just keep in mind that the calculated incident energy is going to increase dramatically. Another consideration is if you have equipment like this that may be accessible from the back. If there's ever a possibility that someone may access the rear of the equipment while it's energized, you may want to rethink this 36 inches. Because 36 inches assumes that the energized conductors are near the back of the equipment. If you're actually accessing the equipment from the back, it's going to be a lot closer. The bus will typically be very, very close to the rear of the equipment, and 36 inches in that case wouldn't be a suitable distance to use. This is a summary of the working distances as they are in IEEE 1584. For cable, which is really an arc flash occurring on the end of a cable in open air, 18 inches is suggested. For low voltage distribution equipment like motor control centers and panel boards, 18 inches is listed. And then low voltage switchgear, 24 inches is listed. And then the medium voltage equipment such as 5 kV and 15 kV switchgear, 36 inches is listed. The title for Article 105 has been modified. Application of safety-related work practices and procedures. The new text "and procedures" was added to this title. 105.3 responsibility. This section was revised and it was divided into two new sections. The two new sections include employer responsibility and employee responsibility. For employer responsibility, this new text requires that safety-related work practices and procedures required by this standard shall be established, documented, and implemented by the employer. In addition, provide training in employer safety-related work practices and procedures for employees. The employee responsibility is that the employee shall comply with the safety-related work practices and procedures provided by the employer. 105.4 priority is another new addition for 2018, and this addition emphasizes that hazard elimination shall be the first priority in the implementation of safety-related work practices. There's an informational note that emphasizes that elimination is the first risk control method listed in the hierarchy of risk control. And basically, elimination is always job one. Eliminate the hazard. That's part of what establishing an electrically safe work condition is all about. Eliminate the hazard. As part of the electrical safety program, 110.1b inspection was added. And this new addition requires that the electrical safety program includes elements to verify that newly installed or modified electrical equipment or systems have been inspected to comply with applicable installation codes and standards prior to being placed into service. Condition of maintenance. The word condition was added. Previously, this simply was maintenance. Risk assessment procedure. The risk assessment procedure has two new additions. In addition to identify hazards, the new additions are for human error 110.1H2 and 110.1H3, hierarchy of risk control methods. Let's take a look at each one of these individually. Human error was added to address the potential for human error and its negative consequences on people, processes, the work environment, and equipment. Let's face it, things happen. The hierarchy of risk control, This was part of NFPA 70E in 2015, but it was an informational note. It wasn't part of the mandatory language. So now the hierarchy of risk control methods is part of the mandatory language beginning in 2018. And the hierarchy is number one, always, first and foremost, eliminate the hazard. Number two, substitution. Number three, engineering controls. Number four, awareness. 5, administrative controls, and 6, PPE. And this goes from the most effective method of risk control to the least effective. And the most effective is eliminate the hazard, eliminate the risk. And people will say the least effective is PPE, and you think, well, wait a minute, if I'm involved in an arc flash, I would hope the PPE is very effective. Well, it should be very effective in protecting you. But as far as trying to control the risk, it's the least effective because apparently you didn't control the risk and the arc flash occurred. So it's referred to as the proverbial last line of defense. Everything else went wrong, and that's all that's standing between you and a severe injury or worse. 110.1i, Job Safety Planning and Job Briefing. Job safety planning was added to the title, and it was divided into two separate parts, job safety planning and the second part, job briefing. Some of the information that was previously included as part of the job briefing has now been moved over to job safety planning, and it's provided in a list type of a format. Another new addition is for incident investigation. And this requires that the electrical safety program include elements to investigate electrical incidents. This picture is actually from an investigation that I was part of a couple of years ago. It was a nuclear plant. It was actually in Japan that had a pretty horrific fire as the result of the Fukushima earthquake. And so basically it was a recreation to see if an arc flash could catch this equipment on fire, which, oh yeah, this was one of the better reenactments and investigations that I took part of. 110.1k auditing also had some revisions. The words electrical safety were deleted from the title, and the word audit was added to electrical safety program audit, fieldwork audit, and lockout, tagout, program, and procedure audit. Lockout, tagout, program, and procedure audit. This new addition is based on relocating 120.2C3, and in addition, the audit shall be designed to identify and correct deficiencies specified in the following: the lockout, tagout program and procedures, the lockout, tagout training, and worker execution of the lockout, tagout procedure. Contact release. The requirements were expanded from employees exposed to shock hazard to include and those responsible for the safe release of victims from contact. First aid, emergency response, and resuscitation. The 2015 edition stated that the refresher training needs to occur annually. However, this introduced a bit of a contradiction because the American Red Cross has a 2-year certification period for CPR. So this was changed for 2018 that says at a frequency that satisfies the requirements of the certifying body. 110.3A2, host employer responsibilities. A new informational note was added that provides examples of a host employer, and these examples include the owner or their designee, the construction manager, a general contractor, or the employer. Test instruments and equipment. This used to be referred to as use of electrical equipment, and the title was changed to what we see here, test instruments and equipment. Furthermore, there was language referencing the limited approach boundary as well as electrical hazards, and that was deleted. So now the part that said within the limited approach boundary has been removed, and this now reads, only qualified persons shall perform testing, troubleshooting, and voltage measuring on electrical equipment operating at voltages equal to or greater than 50 volts AC or 100 volts DC. And also an informational note, there was a reference to ANSI ISA 61010-1. That was deleted and replaced with a reference to UL 61010-2-033. 110.5, portable cord and plug connected equipment. The title was changed. It used to be portable electric equipment, and now it also added the cord and plug reference. The information in this section was previously found in 110.4b. GFCI protection, or ground fault circuit interrupter protection, as it's referred. This information was previously located in 110.4c and d, and was relocated to 110.6. Article 120, establishing an electrically safe work condition. This was completely reorganized. It was 120.1, verification of an electrically safe work condition. 120.2, de-energized electrical equipment that has lockout tagout devices applied. And 120.3, temporary protective grounding equipment. The new structure is 120.1, the lockout tagout program. This is followed by 120.2, the lockout tagout principles, 120.3, the lockout tagout equipment, and then 120.4, lockout tagout procedures. So this goes from program to principles to equipment, then on to procedures. 120.5 is the process for establishing and verifying an electrically safe work condition. That happens after the first four. So this is more of a logical progression of steps for the process. As part of the reorganization of Article 120, the section regarding lockout tagout auditing was relocated to 110.1. Lockout tagout training was relocated to 110.2, electrical safety training, and temporary protective grounding equipment was relocated to 120.5. 120.1a, general, this section states that each employer shall establish, document, and implement a lockout tagout program. And the lockout tagout program and procedures shall also incorporate the following items. Number 1, be applicable to the experience and training of the workers and conditions in the workplace. Number 2, meet the requirements of Article 120. And number 3, apply to fixed, permanently installed equipment, temporarily installed equipment, and portable equipment. The employer responsibilities define the general requirements of a lockout tagout program and specifically defines the employer responsibilities as providing the equipment necessary to execute the lockout tagout procedures, providing lockout tagout training to workers in accordance with 110.2, and auditing the lockout tagout program in accordance with 110.1. Auditing execution of the lockout tagout program in accordance with 110.1 is also a responsibility of the employer. 120.2a, general, this states that the requirements of Article 120 must be met in order to have an electrically safe work condition. And with that, the employee involvement requires that each person who could be exposed directly or indirectly to a source of electrical energy shall be involved in the lockout tagout process. Notice the word indirectly as well. A new informational note provides examples of direct and indirect exposure. Lockout tagout procedure. This was previously referred to as the plan. This language was relocated from 120.2b5, and the language, a lockout tagout procedure shall be developed and suitable documentation, including up-to-date drawings and diagrams, was added. That's always a bit of a trick when you're trying to put together a lockout tagout procedure, or reviewing where the sources of energy are, or even actually when you're trying to perform an arc flash study, trying to come up with up-to-date drawings. That's sometimes a bit of a trick. If you go to a site, and I've done this before, and you ask, do you have an electrical one-line diagram? Some places will have a diagram. Others look at you like they're not really sure what you're talking about. And then you get to the point about, is it up to date? Well, it was up to date in 1977. Yeah, that's not quite what we're looking for. So part of this may actually be bringing drawings up to date to reflect whatever the current conditions are. 120.3 Lockout Tagout Equipment. This is based on relocating 120.2E, and it covers the requirements of lock application, lockout tagout device, lockout device, and tagout device. 120.4 Lockout Tagout Procedures. This section is derived from relocating other sections from the 2015 edition. 120.4A4, an exception, the lockout tagout is not required for work on cord and plug connected equipment if exposures to the hazards of unexpected energization is controlled by unplugging the equipment from the energy source, as long as the plug is under the exclusive control of the employee. The process for establishing and verifying an electrically safe work condition has been relocated from 120.1 to 120.5, and in addition, two additional steps were added, which include release stored electrical energy, such as from capacitors, and release or block stored mechanical energy. (130.12) General. The text, the electrical safety related work practices when an electrically safe work condition cannot be established, was changed, and it now is requirements for work involving electrical hazards, such as the electrical safety related work practices, assessments, precautions, and procedures. Electrically safe work conditions, new text was added, operating at voltages equal to or greater than 50 volts. And this was a change from what was originally in the 2015 edition, and the full text reads, energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts. It used to have AC and DC separately, now it just says 50 volts, shall be put into an electrically safe work condition before an employee performs work if any of the following conditions exist. And these are the conditions that we've had in the past. Number one is if work is being performed within the restricted approach boundary. And number two is the interaction clause, that if there's interaction, that could lead to a hazard, such as an arc flash hazard. In addition, the exception regarding disconnecting means or isolating elements was deleted. The conditions that need to be met for normal operation, these are the original 5 plus the new one. The equipment has to be properly installed. The equipment is properly maintained. The new edition, the equipment is used in accordance with instructions included in the listing and labeling and in accordance with manufacturer's instructions. Number 4, equipment doors are closed and secured. 5, all covers in place and secured. And 6, no evidence of impending failure. With the exception of item number 3, the original 5 items were introduced in the 2015 edition of NFPA 70E. And this is really to help with the question about interaction. When the language about interaction could possibly cause an arc flash, and that's been reworded now in recent years, but with interaction potentially causing an arc flash, there was a lot of confusion about what does that actually mean. And there have been many attempts to try to clarify that. And in 2015, the steps for normal operation were introduced. And now in 2018, the new step about operating in accordance with the instructions and so forth has been added. There was a change made to when an energized electrical work permit is required. When work is performed as permitted in accordance with 130.2a, an energized electrical work permit shall be required under any of the following conditions. That text is actually referencing now 130.2a. The following conditions include when work is performed within the restricted approach boundary and interaction that can increase the likelihood of injury from an arc flash. And that was the interaction that I was mentioning just in the past slide. This was actually introduced, the reference to interaction, in the 2009 edition of NFPA 70E. And the steps for a normal condition, normal operating condition, that was introduced in 2015 to help clarify the interaction issue. There are still several exceptions within NFPA 70E where energized electrical work permits are not required. Restricted approach boundary. A minor change made here. It's an approach limit at a distance from an exposed, energized electrical conductor or circuit part within which there's an increased likelihood of electric shock due to electric arc over or inadvertent movement. 130.4 Shock Risk Assessment has been renamed and reorganized. Previously, this was called Approach Boundaries to Energized Electrical Conductors or Circuit Parts for Shock Protection, and it consisted of A, the Shock Risk Assessment, B, Shock Protection Boundaries, C, the Limited Approach Boundary, D, the Restricted Approach Boundary. This was renamed Shock Risk Assessment, and it's now organized as A, General, B, additional protective measures, C, documentation, D, shock protection boundaries, E, the limited approach boundary, and F, the restricted approach boundary. 130.4A, general. This section lists revised requirements for the shock risk assessment, and these requirements include, number 1, identify the shock hazards. Number 2, estimate the likelihood of occurrence of injury or damage to health and the potential severity of injury or damage to health. And 3, determine if additional protective measures are required, including the use of personal protective equipment. B, shock risk assessment, additional protective measures. So there's new language that refers to the hierarchy of risk control. And when additional protective measures include the use of PPE are required, the following items shall be determined: the voltage to which personnel will be exposed, the boundary requirements, and the personal and other protective equipment required to protect against the shock hazard. 130.4C, the shock risk assessment is required to be documented. 130.4C, shock risk assessment, table 130.4C-A and B, the title now includes the words shock protection to describe the approach boundaries. And also the word exposed is used when describing energized electrical conductors. There's some minor changes to a few of the restricted approach boundaries as well. The minimum voltage for table 130.4CB, this is the DC table, was changed from 100 volts to 50 volts. 130.4C, table A, this is an illustration of the new words shock protection. So it now says shock protection boundaries, and the word exposed energized electrical conductors. So the word shock protection and the word exposed were both added to the title of this table. 130.5 was reorganized for 2018. Previously, 130.5 general had A, documentation, B, the arc flash boundary, C, arc flash PPE, and D, equipment labeling. The new organization of 130.5 includes A, general, B, estimate of likelihood of severity, C, additional protective measures, D, documentation, E, arc flash boundary, F, arc flash PPE, G, incident energy analysis method, and H, equipment labeling. So this is a more logical progression of the steps for an arc flash risk assessment. 130.5A, general. This section lists 3 items that are part of the arc flash risk assessment. And they include to identify the arc flash hazards, to estimate the likelihood of occurrence of injury or damage to health and the potential severity of injury or damage to health, and finally, to determine if additional protective measures are required, including the use of PPE. 130.5B, estimate of likelihood and severity. This is a new section, and it requires taking into account the design of electrical equipment, including its overcurrent protective device and its operating time, as well as the electrical equipment's operating condition and condition of maintenance. One of the concerns is that part of incident energy calculations, the arc flash duration is defined by an upstream protective device. So the question is, what condition is that protective device in, and will it actually operate as expected? The duration of an arc flash is determined by using the time current curve, typically of the protective device upstream. And this is a time current curve of a 225 amp molded case circuit breaker. On the left, you can see the time scale in seconds. In lower left, it begins at 0.01 seconds. Then it moves up to 0.1 seconds, 1, 10, 100 seconds, and finally at the top, 1,000 seconds. The horizontal scale is current in amps, and it's actually adjusted by a factor of times 10. So in the lower left, we have 0.5, but it's really 0.5 times 10, so it represents 5 amps. The next one is 1, and that's actually times 10, so that represents 10 amps. The 10 represents 100. The 100 times 10, that represents 1,000, and so on. So this time current curve, it's actually adjustable. The vertical band that's on the left that goes all the way to the bottom is considered the low setting, and the vertical band on the right that goes all the way to the bottom is the high setting. And the horizontal band that runs along the bottom part of the graph, that represents the instantaneous, meaning that if a current flows through this device of that magnitude in the horizontal band, it would trip very, very quickly. In fact, with this device, that represents 0.0167 seconds, or 1 electrical cycle. So as an example, where the red line is, let's say that we have a short circuit out at that point. And so we have a short circuit. It would actually be, for our case, an arcing short circuit current. And at that point, this indicates that the device would operate in 0.0167 seconds very quickly. And that would help to minimize the magnitude of the incident energy from an arc flash. But let's say this device was set at a low setting. It's an adjustable device. So let's say it's at the low setting and that we have a reduced arcing short circuit current. Well, where the red line is down at the bottom with the reduced current, the low setting would still trip very quickly, as you can see. But if this protective device were set at the high setting and we have that same lower short circuit current, it misses the tripping characteristic. And this graph indicates that it could take quite a long time to operate. Now, realistically, would it take that long to operate? Probably not, but there's no way to know for sure. Would it self-extinguish? There's a pretty good chance that it would self-extinguish. And IEEE 1584 actually has language that if there's room for escape, if judgment is made, you could actually cap this time at 2 seconds. A lot of people refer to it as the 2-second rule. But in any case, the concern about condition of maintenance and the device is that you're looking at time current characteristics to predict how long the arc flash may last. And unless the equipment is actually in good working condition and good condition of maintenance, you don't really know. The condition of maintenance is very important, and so that's why this article is introduced, to make sure that you have good condition of maintenance and that the devices operate as they should. 130.5c, additional protection measures. This is a new section, and it defines a requirement that if additional protective measures are required that include the use of PPE based on the hierarchy of risk control. Now remember, the hierarchy of risk control begins with elimination of the risk, and then it goes through the hierarchy and ends with PPE. So if we get down to where PPE is required, there are 3 items that need to be determined. Appropriate safety-related work practices, the arc flash boundary, which I'll discuss here in a little bit, and the PPE to be used within the arc flash boundary. Table 130.5c, estimate of the likelihood of occurrence of an arc flash incident for both AC and DC systems. This is based on a table that was introduced in the 2015 edition, and additional language was added that states it shall be permitted to be used to estimate the likelihood of occurrence of an arc flash event to determine if additional protective measures are required. In 2015, the table was 130.7C15A lowercase a, and you may recall that it actually stated is arc flash PPE required in the table. There was a column labeled arc flash PPE required, and there was a simple yes or no. Well, this raised a few eyebrows to actually have a table that says no, PPE is not required. And this time around, it was changed to likelihood of occurrence. The likelihood is there a likelihood of an arc flash to occur? And so in 2015, looking at the far right, it said arc flash PPE required, and that's where you would find the yes or no. And now it has been changed to likelihood of occurrence of an arc flash, yes or no. A new table was introduced for 2018. It's Table 130.5G for the selection of arc-rated clothing and other PPE when the incident energy analysis method is used. Now, the incident energy analysis method that's outlined in NFPA 70E, that typically is what most people think of as an arc flash study that's based on IEEE 1584. That includes calculations of arcing short circuit current, of the incident energy at a specific working distance, as well as the arc flash boundary. And so this new table, it's been added, and it shall be permitted to be used with the incident energy analysis method for selecting arc flash PPE. This new table is derived from information that was previously located in the annex in Table H3B. 130.5H, equipment labeling. There were a couple of changes made to 130.5H. I want to give a little bit of a review first, that for equipment labeling, what the minimum requirements are is you have the nominal system voltage, the arc flash boundary, and at least one of the following. And the first one is the available incident energy. That would be from incident energy calculations, as well as the corresponding working distance. Now, the reason the working distance is so important is incident energy varies with distance, and it has a little bit to do with the type of equipment as well. Some used to believe that the energy varied as 1 over the distance squared, but it really depends on the type of equipment, and IEEE 1584 has a few different exponents that are used. So it's the available incident energy and the corresponding working distance, typically 18 inches, 24 inches, or 36 inches. So it's that or the arc flash PPE category found in Table 130.7 C15A or B. So you can have that, but not both. And you can also list the minimum arc rating of the clothing if you wish. And you can also list a site-specific level of PPE. And many still like to do this. They will have, for example, the traditional level 2, level 4. Some used to call it categories, but categories are reserved for the NFPA table. And so a site-specific level of PPE, typically you see level 2 and level 4. Level 2 being the equivalent of 8 calories per square centimeter for an arc rating, and level 4 being 40 calories per square centimeter. This is a pretty typical arc flash label. Up at the top is the signal word, and signal words are defined in ANSI, American National Standards Institute, Z535. Warning is commonly used with the background orange. Orange actually goes with warning. And then there is the message panel that states arc flash and shock hazard, basically what is the problem. And then what is the response? Well, appropriate PPE is required. Now, as far as minimum requirements from NFPA 70E, you do have to list the nominal system voltage. That's 130.5H1. And you can see here it says shock hazard exposure, 480 volts. And it also has information about when the covers are removed, when it's exposed. And then we have 130.5H2 that requires the arc flash boundary. And then finally, we have 130.5H3, where we have a list. We select at least one of the following. And in this case, I have the calculated incident energy in calories per square centimeter and the corresponding working distance where that incident energy is based on. This is a more comprehensive arc flash label. Many choose to have more information. So we have the signal word in the warning, and we have an arc flash boundary listed. We have the calculated incident energy and corresponding working distance. And in this case, a site-specific PPE level was given as well, level 2, meaning in this case, 8 calorie per square centimeter for the arc rating. Some will want to list the PPE on the label. I suggest rather than listing the actual PPE, which can change perhaps, reference a separate list, like perhaps reference the latest edition of NFPA 70E or reference particular practices that you may have. That way, if there is a change, you can change the list, but you don't have to go back and change the label. The shock hazard is listed as 480 volts, or many software packages will list it in kV, kilovolts. So this one is in 0.48 kV. The limited approach boundary and the restricted approach boundaries are not required to be on the label, but many people opt to list this on the label more as a matter of convenience. And then we have the class of gloves, as well as a date. Now, the date is not required to be on the label either, but also many people do elect to put the date on the label just so they know when the clock starts running when it comes time to revise or review the arc flash study. And then you could also, optional, you could list what device upstream is feeding this equipment where the label is located, and then who performed the labeling and who performed the study. 130.5H equipment labeling, exception number 1, the language was changed, and it now states that unless changes in the electrical distribution system render the label inaccurate, labels applied prior to the effective date of this edition of the standard shall be acceptable if they complied with the requirements for equipment labeling in the standard in effect at the time the labels were applied. What might render the label inaccurate? Well, a couple of the main things would be if perhaps short circuit current changes from the electric utility company. That may have a minor effect, but if it's a major change in short circuit current that has a significant change in the incident energy that may ultimately affect the arc rating of the PPE. Or perhaps protective device settings changed, or maybe transformer sizes were changed. So there's some judgment required here, and so this is referencing that if there are major changes that have rendered the label inaccurate, then you're going to have to go back and replace the label, update the label. Otherwise, this language states that the label is still acceptable. A new exception was added, exception number 2, and this states that in supervised industrial installations where conditions of maintenance and engineering supervision ensure that only qualified persons monitor and service the system, the information required in H1, H2, and H3 are permitted to be documented in a manner that's readily available to persons likely to perform examination, servicing, maintenance, and operation of the equipment while energized. This is a new exception that was added. Personal and other protective equipment, just in general, this is a big one. So there was a note that stated that if the calculated incident energy exceeds 40 calories a square centimeter, additional emphasis or greater emphasis should be given to de-energizing. And this particular informational note 3, is what often led to some interesting arc flash labels. Quite often, if the calculated energy exceeded 40 calories a square centimeter, rather than using an orange background with warning, it would change to a red background with danger, and quite often it would list no PPE available. And that's not really quite right, because PPE arc ratings go well beyond 100 calories per square centimeter. And the problem was that 40 calories per square centimeter, although that's a lot of incident energy, many were thinking that this was kind of a threshold where it would be more explosive. And the explosiveness of an arc flash isn't so much based on the incident energy, it's more a function of short circuit current. For example, if you have 40 calories per square centimeter, and that occurs over 2 or 3 electrical cycles, yeah, there's going to be quite a bit of an explosive force with that. But if you have 40 calories per square centimeter just because a protective device took a long time to operate, perhaps 60 cycles, maybe 90 cycles, some big number, 40 calories per square centimeter over an extended period of time, that's not going to be as explosive. And so this informational note was actually deleted, and for good reason, because instead, a greater emphasis should always be placed on de-energizing, not just because the calculated incident energy goes above 40 calories per square centimeter. Hand and arm protection. 130.7C7 gives 3 conditions where using rubber insulating gloves without leather protectors is permitted. And number 1, there shall be no activity performed that risks cutting or damaging the glove. I think that one's self-explanatory, but the rubber glove is there to protect you from electric shock and electrocution. And if there's a cut or something similar, well, that could expose you to a pretty significant electrical hazard. Number 2, the rubber insulating glove shall be electrically retested before it's reused. And number 3, the voltage rating of the rubber insulating gloves will be reduced by 50% for class double-aught gloves and by 1 whole class for classes 0 through 4. NFPA 70E previously listed specific standards for personal protective equipment and ARC-rated clothing, ASTM standards to be specific. And for 2018, there was a pretty significant change. The reference standards that were listed in Table 130.7C14 have been replaced with language that just says PPE shall conform to applicable state, federal, or local codes and standards. So what originally was a list of standards as part of the mandatory text of NFPA 70E have now been moved to informational notes. As part of this, conformity assessment is being introduced, and this section requires that all suppliers and manufacturers of PPE shall demonstrate conformity with an appropriate product standard by one of the following methods. Self-declaration with a supplier's declaration of conformity, self-declaration under a registered quality management system, and product testing by an accredited laboratory and supplier's declaration of conformity, or certification by an accredited independent third-party certification organization. References to specific standards were also deleted from 130.7E1, safety signs and tags. In particular, ANSI Z535 was referenced in the past that defines the signal words caution, warning, and danger, as well as the associated colors and even to the point of font styles to be used. So now in its place, there's a reference to applicable state, federal, or local codes and standards. .205.3 General Maintenance Requirements. A new informational note number 2, was added, and this note states that non-contact diagnostic methods, in addition to scheduled maintenance activities of electrical equipment, can assist in the identification of electrical anomalies. This is quite an important note because it emphasizes the importance of the maintenance of electrical equipment as well as the condition of maintenance of electrical equipment. 240.1 Batteries and battery room ventilation. The language was changed to when ventilation systems are required by the battery system design and are present. It was a text change. Originally, this stated ventilation systems forced or natural, and now it begins with when ventilation systems are required by the battery system design and are present. 350.4 The Electrical Safety Authority. This is new. And the Electrical Safety Authority, the acronym is ESA, this section permits each laboratory or research and development system application to assign an electrical safety authority to ensure the use of appropriate electrical safety related work practices and controls. Well, that may take a little time to digest. Quite a significant number of changes this time around. Remember, even though sometimes the language in NFPA 70E can appear to be overwhelming, it's written to help make working on or near electrical power systems and equipment safer for all. Remember, the safest electrical equipment is equipment that's been placed into an electrically safe work condition. De-energized, that's Rule number 1. Thanks for watching.